So just to go back a little bit, you guys are familiar with some of this terminology, but just as a review, so you guys know what the heck we're looking at when we look at these during the lesson. For example, we have the cycle. The outside of the cycle is called circumference, which is actually kind of a long word for a math class, but either way, there it is. The circumference. Why they didn't just call it perimeter? I don't know. Because it's a cycle. In any case, we got diameter, radius, and circumference, which we have right here. There's one that's missing, though. That is called the point that's right in the middle of the circle, which we also call the center. Bam. Now, I may not have put that right in the center, but that'll do for our purposes. Now, from right here, what we would do is let's connect the center of the cycle to any part of the outer edge of the cycle along the circumference. All right, there we go. The distance from the center of the cycle to any edge of the cycle is called the radius. Well, if I take any point on the edge of the cycle along the circumference, like maybe about right here, let's make that a different color. There we go. And let's say I connect this point through the center to the other side of the cycle. All right, so I got this line now. That's close enough to the center. I'll just make it bigger, that's better. All right, this is called the diameter. Bam. That's correct. Straight line through the center, the cycle. Now, there are other parts of cycles that we could talk about, like chords and stuff, but we'll save that for 9th grade, because we're not so concerned about those. Yeah, then you got different types of cycles that aren't really cycles, they're just elongated, like ellipses. All right, well, cycles have stifled man, or they did stifle mankind. So both men and women for many, many, many millennia. They were concerned because there was a clear relationship, but they couldn't figure out what the heck was going on until someone, at some point, in some time, figured out that if you took the circumference, and let's say that we divide this extremely long word by the diameter. Now, it wouldn't be just this cycle right here, but as it turns out, any cycle, because all circles are scaled versions of each other. And if we simplified these fractions, you would always, every time, no matter what, the size of the cycle is, big or small, maybe you're talking about the circumference of a planet, or a solar system, or the circumference or diameter of a tiny molecule, all right? No matter what, the circumference divided by the diameter is what they call pi. Now, this is the value that evaded mankind for so many millennia because it's such an unusual number. For example, if we look, pi has a value 3.1415, and then it goes on. As it turns out, it goes on forever, but it never repeats or terminates. It is considered irrational because of that decimal value, and that's what made it so hard to calculate. In any case, if you don't have a pi button on your calculator, this is the value we will be using. I have a button on my calculator, so the values we see on this assignment will include the pi button value. All right, so yes, this begs the question, is this why pies are circular? No, that has to do with cooking. Pies are circular because circular objects cook more evenly than... I do a lot of cooking, as it turns out. Is that not obvious how fat I am? The ratio of any cycle, if you found it, would be the circumference. If you took the diameter of that same circle, you would always get this value, 3.1415 and some other garbage. This is just showing a relationship, that there's a constant relationship between circumference and diameter. Okay? Now, with these, we need to be able to tell, or how to solve for circumference. Circumference, C, will always equal the diameter, and then we would multiply that by pi. Now there's another way we got to look at these. The circumference can also be found by a relationship with the radius. You guys see this radius? How much of the diameter is the radius? Half. So how many radiuses make up a diameter? Two. So I could also just say I'm going to take 2 of my radiuses and then multiply that by pi. By the way, all this is multiplication. So we can show the multiplication right there. For each of the circles below, calculate the circumference of the circle. But we need the answer in 2 ways. One is the exact value, which means that it will include the pi in the answer. The estimation or approximation will be the decimal value to the nearest tenth. So we'll show how this will look on the first one right here. Yeah, these of course are not drawn to scale. And we don't really care about that because all circles are scaled versions of each other. Alright, so we're trying to find the circumference on this one. And we just saw that the circumference is 2 times the radius. And then we would multiply that by pi. So the circumference would equal 2 times the radius, but the radius, right here, it shows as 0.5. So 2 times 0.5 is 1. And that would be 1 times pi. This is the exact answer. So 2 times the radius give us the diameter, which is 1. So now we've just written this in terms of the diameter instead of the radius, which is the exact answer, 1 times pi. Yeah, if you wanted to make that a phantom one, that's okay. Yeah. I'm going to keep it as 1 pi though. But either way works. Yes, now we take at these. And to find the approximation, I'm going to take 1 and multiply it by pi, which would give me, on my calculator, 3.1415, and then a 9er or something like that. Alright, so something like this, but this one told us specifically to round to the nearest tenth. So I look to the decimal value to the right of the tenths, which is the hundredths. That's a 4, which means I will not be rounding the 1 up to a 2. And then I just have my answer right here. Now keep in mind that the answer to this problem is not 3.1, nor is it 1 pi. That is correct. We must label these in centimeters and centimeters. And this one would be the approximate answer. There it is. I may have spelled that wrong, but whatever. Alright, this one gave us the diameter, which is 2.5, and we know that the circumference is found by taking the diameter, which in this case is 2.5, and I would multiply that by pi. Now again, this is the exact answer, so that's one of our answers right here. But then I want the approximation, which would be the circumference, equals 2.5 times a pi, which would be 7.8531, some garbage. In any case, again, we're rounding this to the nearest tenth. Now this is a 5, the hundredths place. So I'm going to have to round that 8 up to a 9er. And one other thing on both of these, we must label. So that would be 2.5 pi centimeters. And this is 7.9 centimeters approximately. Now this is an approximation, so technically you can show the approximation symbol, which is 2 wavy squiggly equal signs like these. I'm not so concerned about that right now because we said in the words that it is already an approximation, but it may be a good thing to show. There it is. Alright, good luck.
Okay, so to find the circumference with the radius, you do the radius times 2, and that would be 6, and then you do times pi, and that equals 18.84. and then you would round down since it's 4. So it's 18.8.
Excellent. So yes, we do need both of those, right? We need the 6 pi, and that's in units, by the way. And that's in units as well. So the circumference is both of these. That's excellent. That's the exact answer, and there's the approximation. All right. If the circumference of a circle is 8 pi, now I'm going to write the formula out right here. So it's telling us that the circumference is 8 pi inches. Which of the following is true? Rewrite false statements to make them true. So A, the ratio of circumference to diameter is 8. Is that correct? It's asking if the ratio for the circle of circumference to diameter is 8. All right, this one, as it turns out, is false. Well, yeah, we guess so.
Wait, I don't.
I didn't guess
So
that.
why is it false, though? That's what we got to figure out right now. It's because the circumference to diameter ratio for any circle is pi. The radius of the circle is 1/2 the circumference. True or false?
False.
False is correct. The radius is actually 1/2 of the diameter. All right, the diameter of the circle is twice the radius.
True.
That's a true. That's true for any circle. The radius of this circle is 8. That one is false. What does the 8 represent in this right count? It represents the diameter, which is the next part. E, the diameter of the circle is 8 inches. True. So in other words, if we went into this circle, let's say we made this, that's a square. Let's make a circle. So if this was the circle right count, then we would have in the middle, the center, and then we would make the diameter would be 8 units right there. Or inches, I guess. So that's a picture of what this would look like.
Wait.
So we have this circumference. We'll start with the bike tire up in here. And we will need to find the diameter, not the radius on the here. Alright, so let's look at that formula once again. The circumference is the diameter times a pi. And we're rounding these to the 10th. So how do I solve for diameter right here? I would divide both sides by pi. Now I will see I get those cancel out right. It's right there, right? Yeah. So I got circumference divided by pi, and they gave us the circumference, which was extremely generous. And the circumference is 76.9er. So I'm going to plug this in my calculator, and I will round it to the nearest tenth. All right, 24.7803 or something like that. Let's round it. 24.47, thank you. So we're going to round that to 24.5. But the answer is not 24.5.
Inches.
Inches. Bam. There it is. All right, once again, we can see the circumference is the diameter times a pi. So to find the diameter, we're going to divide both sides by pi. And then we got the circumference divided by pi equals the diameter. And for the car tire, they gave us a circumference of 78.1. This one should be pretty close to the last one, right?
It's 24.86, so I got 24.9.
24.86.
So
So 24.9. Very good.
Okay.
The answer is not 24.9 though.
Inches.
Inch. Bam.
Radius.
The diameter or radius of these objects is given. Calculate the circumference of each object to the nearest tenth of a unit. Alright, so let's look at the masking tape. So we got the diameter of this masking tape is 5, so it's 5 units. Now the circumference is what we want. So we're going to have to multiply that 5 times a pi. And that should give us, all right, but the answer is not 15.7.
Inches. 15.7 inches.
Inch, very good. Next up, we'll do the Ferris wheel. We'll do the ring later. So the Ferris wheel up and down. The circumference is the diameter times the pi. And they gave us the diameter right here, which was 50.
50 times pi.
50 foot. So we're going to multiply 50 times the pi. And when we do these, 157.1
inches.
Now this one actually, that's only one mark right there, so that'd be foots.
Oh.
There we go. When a unicyclist pedals once, the wheel makes one full revolution. When the unicycle moves forward the same distance along the ground as the distance along the edge of the wheel. If Daniel is riding a unicycle with a diameter of 20 inch, how many times will he have to pedal to cover a distance of 50 foot? Alright, so since we're looking at the unicycle in inch, we need to change this 50 foot into inches. So we're going to have to multiply these by 12. And that would be 600 inch. So Daniel is going to travel 600 inch, which is the same as 50 foot. Now we got to figure out how many times he's got to pedal this garbage. So the diameter is 20 inches, not the circumference. But the circumference will tell us how far he traveled for each one revolution. So we need to find the circumference of the wheel by taking the diameter, which is 20, and multiplying by pi. That would be the circumference. So if we round at these, 62.8. Give me two more decimal places.
3-1.
831. And that would be in inches, right here. Now this is the circumference of the wheel. What we really need to do is figure out how many of these circumferences are in the 600 inch. So how many circumferences are there? How would we figure this out? Yeah, very good. 600 inch divided by 62.831 inches. And that's per revolution. So this answer, so 5.549, something like that. 5.4. Yes, very good.
9.5.
Now the question is, what is the label on it, these?
V.
Pedals. I'm going to put revolutions on this. Yeah, times is better. 9.55 times pedals. You have to pedal this thing to cover a distance of 50 foot.
Okay.
Back to number 9er. Alright, the baked beans, the circumference of the lid is 11 inches. So we will find the diameter on this one. Now remember, the formula is circumference equals the diameter times pi. And on this one, they gave us the the circumference, which is 11 inches. So I replace that with 11. And then I solve this just like I would a regular equation. So I don't want d, I want 1d, not pi d, or d pi. So I would divide both sides by pi, right here. And then that would tell me, because the pi's cancel, what the diameter is. Alright, 3.50 it is. But again, the answer is not 3.5. This one would be 3.5 inch. There we go. Alright, let's do the garbage can now. So this one now has a circumference of 50 inches. So I'll make that 50 inches equal to the diameter times pi. Because the circumference is the diameter times pi. So using the same method, I'm going to divide both sides by pi. So that these pi's cancel out. And I've got my diameter, which is, alright, 15.915, but we're just rounding to the 10th. So we'll make that 15.9 inch. All right, the plate, this one has a circumference of 31 inch. So my circumference, 31 inches, will equal the diameter times pi. So to solve these, we'll divide both sides by pi. And then the pi's cancel, giving us just the diameter, which is 9.86 would round to 9.9, and this one is inches. So yep, that would be our answer right there. 9.9 inch diameter, approximately. All right, on this one's, so we want the circumference, and this one gave us the radius. So I'm going to use the radius equation for this one. So the circumference is 2 times the radius times pi. But on this one, we know the radius. Yeah, so that would end up being 22 times pi, which is?
69.11.
Yeah, rounding this, 69.1 inches. All right, let's do the ring now. So the ring already has the diameter, so we got the circumference will be 2.5. 2.5 times pi. 2.5 times pi is... All right, so the ring ends up being 7.9 centimeters after we round. Bam. So yeah, on this one, the ring gave us the diameter, so there was no need to take that 2.5 and multiply it by 2. And we're good to go on that one. All right, so to find the circumference of the steering wheel, we're going to take 2 times the radius times a pi. Well, we already know the radius is 9 in inches. So I can plug this directly into my calculator. 56.5 inch. Bam.